Questions 11 through 20 on the 2013 Grade 10 AMC 10B. Real numbers x and y satisfy the equation x squared plus y squared is equal to 10x minus 6y minus 34. What is x plus y? Several approaches to this question. I'll just use the approach that I like. X squared plus y squared is equal to 10x minus 6y minus 34. Put everything on one side. X squared plus minus, I should say, 10x plus y squared plus 6y plus 34. Well, complete the square. By completing the square, you'll be able to get the answer. Take half of this and square it. So minus 5 squared is 25. And then immediately you have to subtract it. And very similarly, take half of that and square it. 3 is half of 6. If you square it, you get 9. And then immediately subtract that 9 and plus 34. What that allows you to do is factor these guys right here very nicely. You get x minus 5 squared. And here you get y plus 3 squared. And all these numbers can combine. Minus 25 minus 9 is minus 34, plus 34 is 0. So very nicely, that all cancels out. So now we're left with this. The only way this is true is something squared plus something squared equals 0. The only way that's true is if this is 0 and that's 0. So if this is 0, that means that x is 5. And if this is 0, that means that y is negative 3. So they want x plus y. X plus y will be 5 plus negative 3, and that is equal to 2. So number 11, the answer is B. Let S be the set of the sides and the diagonals of a regular pentagon. A pair of elements of S are selected at random without replacement. What is the probability that the two chosen segments have the same length? This is approximately what a regular pentagon looks like. And the word regular means that all the sides are the same. So immediately we know that those 5 sides are the same. And then when you draw diagonals like that, all these diagonals from one side to the other, those diagonals are also the same in terms of their length. So basically what we have is 5 sides. We'll call it S1, S2, S3, S4, and S5. And we have 5 diagonals, D1, D2, D3, D4, D5. And what they're saying is that if you choose you choose a 2 at random, what is the probability that they're going to be the same? So either you're going to get 2 S's or you're going to get 2 D's. All right, well, like any probability question, it's going to be a fraction, something over something. The denominator is the total. What goes here is the total. Well, the total is total number of ways of choosing 2 from 10. Well, that's 10 choose 2. And then in order to get a pair of S's or a pair of D's, from the 5 S's, choose 2. That's my numerator. And then I also have to take into consideration 2 D's. So from 5 D's, I choose 2. So that is the probability. Let's see what this works out to. 5 choose 2 is 5 factorial over 3 factorial over 2 factorial. And there's 2 of these guys, so we can just multiply by 2. 10 choose 2 is 10 factorial over 8 factorial over 2 factorial. So this looks like 2 times 5 times 4 divided by 2. And this is 10 times 9 divided by 2. So this is 20 over 45. And if you divide top and bottom by 5, you'll get 4 over 9. So there you go. That's the probability. So number 12, the answer is B. Joe and Blair take turns counting from 1 to 1 more than the last number said by the other person. Joe starts by saying 1, so Blair says 1, 2. Joe then says 1, 2, 3, and so on. What is the 53rd number said? So the first person says 1, the next person says 1, 2, the next person says 1, 2, 3. The next person then says 1, 2, 3, 4. And then the next person says 1, 2, 3, 5, and so on, right? You get the pattern. So we have to make this list long enough so that I eventually get to the 53rd number that has been spoken. Well, I think I'll have to probably do a few more. 1, 2, 3, 4, 5, 6. Oh, I forgot a 7. 7, 8, 9, 10. And in this list, we now have to count 53. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53. And that is an 8. I'm sure you have a quicker way of doing it by adding, all that. And that's fine. Whatever way works for you. So number 13, the answer is 8, and that would be choice E. Define a symbol b as a squared b minus ab squared. Which of the following describes a set of points for which x symbol y is equal to y symbol x? Well, x symbol y is equal to y symbol x. And if we do the definition according to the question, this would basically mean x squared y minus x y squared, and on this side it would be y squared x minus y x squared. Combining like terms, it would be 2x squared y, and on this side it would be 2xy squared. Okay, divide through by 2, and I'll be just having x squared y and xy squared. Factor out an xy on both sides, and you will have on this side just an x, and on this side you will have a y. Okay, very interesting here. Well, when is this true? This is true, for example, if x is 0, that would wipe out everything. This is also true when y is 0. And if x is not 0 and y is not 0, then I can get rid of xy from both sides, and it would just leave me with x minus y. So these are the three scenarios where this equation is true. All right, well, let's graph those, see what those look like on a graph. So here's my graph. The first one, x equals y, is just a line, right? X equals y is a line that goes right through like that. So that takes care of this guy. X equals 0, well, that's just, x equals 0 is just the y-axis, interestingly. And y equals 0 is the x-axis. So let's to recap here. This is x equals y, this line that's going from there to there. X equals 0 means that it's essentially the y-axis, and y equals 0 is the x-axis. So what that means is you got three lines. This is your first line right here, this is your second line right here, and this is your third line right there. So three lines is the description for the set of points that satisfy that equation, and therefore number 14 would be E. A wire is cut into two pieces, one of length A and the other length B. The piece of length A is bent to form an equilateral triangle, and the piece of length B is bent to form a regular hexagon. The triangle and hexagon have equal area. What is A over B? We initially have a wire, and we take part of it, that is the segment from, let's say, here to here, and it has a length of A, and then the other segment is from there to there, and it has a length of B. Then what we do is we use A to make an equilateral triangle, like that. And then we take B, and this is not drawn to scale, but we make a hexagon, a regular hexagon, so that all the sides are the same. And again, definitely not drawn to scale. But that is the way it's done. Now, each of these sides is the same, so that means each of these sides is A over 3, right? Because the total wire is A. Now, each of these sides has got to be B over 6 because each of those has to be equal. And now what they're saying is that the areas of these two shapes are equal. So we have to figure out the area. All right. Well, we're going to probably have a whole bunch of 30, 60, 90 triangles in here, most likely. And that's going to allow us to figure out these areas and the distances. Well, this is H from top to bottom. And this is, of course, 60, and this is 90, since that's a perpendicular, and that's 30. So using the ratio of the sides, as I'm sure you know by now, it's always going to be 1 root 3 and 2. So, for example, just to recap, if you have any 30, 60, 90 triangle, and it has the angles like this is 60 and this is 30, the ratio of the sides is 1 root 3 and 2. Not necessarily the distance, but the ratio. So using that, we can easily figure out a relationship between H and A. Now keep in mind, we're going to look at that part, not the whole base. The whole base is A over 3, so just this part is half of that, so that's A over 6. So H over A over 6 is equivalent to root 3 over 1. So that means H is equal to root 3A over 6. And therefore the area is 1/2 base, which is A over 3, times height, which is root 3A over 6. And if you combine this, you get root 3A squared over 36. All right, so that's pretty straightforward. Hexagon, a little bit more work here. We have to label a couple more things. Well, from here to here, I'll label that X. And from here to here, I'll label that Y. And again, this is going to be a 30, 60, 90 triangle. This is, of course, a right angle. This angle in here is going to be 30. And this angle in here is going to be 60. Because interior angles of a hexagon are 120. And since this is a right angle, that means that's got to be 30. And then, of course, the other one is going to be 60. So, again, using 30, 60, 90 triangles, X over B over 6 is equivalent to root 3 over 2. And therefore, X is the same as root 3 over 2 times B over 6. All right? And then similarly, Y over B over 6 is equivalent in terms of the ratios to 1 over 2. And that means Y is equal to B over 12. All right, so now we got to figure out the area of this guy. Well, it's going to be first the rectangle, so that's B over 6 times 2x, not just x, but 2x. So 2x is going to be 2 times root 3 over 2 times B over 6. And then we have to add these two triangles, this one and the other one, but they're identical. So it's 2 of them. So 2 times 1/2 base times height. Base is x. Actually, 2x is the base. Just be careful that you put 2x. So that's going to be 2 times root 3 over 2b over 6. And running out of space here. And then the height, which is y, which is b over 12. All right. And this simplified, let's see here, we're going to have 2 root 3b squared over 2 times 36 and plus root 3b squared and also 2 times 36. All right, so this area is the same as that area, so that means this is the same as that. So I've got to equate those two. That's my final step. So root 3a squared over 36 is the same as 2 root 3 plus root 3, that's 3 root 3 b squared, and that denominator is 2 times 36. Well, let's get a common denominator, multiply top and bottom by 2. The denominators vanish, And all I'm left with is 2 root 3 a squared is equal to 3 root 3 b squared. Put the a squared over the b squared because we want to get a over b. And that means you got 3 root 3 over 2 root 3. And that's going to be 3 over 2 is a squared over b squared. Take the square root of both sides and we get a over b is equal to the square root of root 3 over 2. Now that's not one of the answers, but that's okay. It just means that we have to get it in that form. So let's see here. Root 3 over root 2. Rationalize the denominator top and bottom by root 2. That means we have root 6 over 2. Root 6 over 2 is the answer. So number 15, it's B. In triangle ABC, medians AD and CE intersect at P. PE is 1.5, PD is 2, DE is 2.5. What is the area of AEDC? AEDC would be that section right there. Well, let's label this. PE is 1.5, and then PD is 2, and DE is 2.5. Okay? Well, one thing I immediately notice is that this is a right triangle, right? Because 1.5 squared plus 2 squared is equal to 2.5 squared. It's basically half of a famous 3, 4, 5 triangle, right? If you doubled the side lengths, it would be 3, 4, and 5. And many of you know that is a right triangle. They just cut it in half. So that means this little guy in here is a right triangle. Now, they told me that these are medians. This one right here, AD, and this guy, CE. And there's a property that if you draw those two medians and they meet, like they do here, this P is known as a centroid. So just type that in, centroid, this guy right here. And the centroid has a property that it divides each median in a 2-to-1 ratio. So what that means is that if PD is 2, then AP will be double that, so it'll be 4. If PE is 1.5, then CP will be double that, which is 3. And there we go. We have everything we need now to figure out the area of AEDC. Since that's a right triangle, this is also right, and this is also right, and this is also. So you got all these right triangles, right? So that makes it easy for us to figure out the area. AEDC is going to be 4 triangles that we figure out with 1/2 base times height. So let's do this one first. 1/2 base times height, so 2 times 1.5. And then the next one, this guy right here, 1/2 base times height, so 4 times 1.5. And then the next one, we can use this triangle, so 1/2 base times height. And finally, this triangle, which is 1/2 3 times 4. And when you do the math there, we get 1.5 plus 3 plus 3 plus 6. So that's going to be 13.5. And therefore, number 16, the answer is B. Alex has 75 red tokens and 75 blue tokens. There is a booth where Alex can give 2 red tokens and receive in return a silver token and a blue token. And another booth where Alex can give 3 blue tokens and receive in return a silver token and a red token. Alex continues to exchange tokens until no more exchanges are possible. How many silver tokens will Alex have at the end? Let's make a table here and we shall proceed. And I'll try to do this in a way that is easy to understand. So my solution is going to be a little longer than obviously you have time on in a math contest, but I'm just trying to explain it. So first, let's write out our fundamental rules up top so that we always have them. 2R is exchanged for 1 silver and 1 blue. And 3B, 3 blue, is exchanged for 1 silver and 1 red. All right, so we can proceed with these rules. And of course, at the very beginning, we have 75 red, we have a 0 silver, and we have 75 blue. So let's start. Our goal is to get 3B, right? So what I'm going to do is first use this rule right here. And that rule I'm going to use 3 times in order to get 3B. So I got to start with 6R. And when I do, I will get 3S plus 3B. And then now that I have this 3B, I can now utilize that rule. And when I do, that 3B will now convert to S plus R. So let's make a tally here. Initially I started with 75, but I used 6, so I'm down to now 69, correct? So I'll put that 69 in there. And then I got 3S and 3B, so this went up to 3 and this went up to 78. But then I used those 3B, so this went back down to 75, but then I got an S and an R, so this went up to 4, and this went up to 70. All right? So I'll just do a couple more, doing the exact same thing. Nothing different. Exactly what I did. And when I do that, I get the same results. What would happen is I would get now, I've used 6R, so this would go down to 64, but I get 3S, so this goes up to 7, and I get 3B, this goes up to 78. But then once I do this, I use 3B, this goes back down to 75, I get an S, this goes up to 8, and I get an R, this goes up to 65. All right? Do it once more, we get very similar results. You use 6, so this goes down to 59. I get 3S, this goes up to 11. I get 3B, this goes up to 78. And then once I do this, I go back down to 75, but I get an S and I get an R. So there we go. So you get the hang of it. And if you keep doing this, over and over and over and again, eventually you'll get down to a situation where you have 5 here, you'll have 56, and this always tends to go back and forth between 78 and 75. So it's easy to figure out that because it's just going up by 4 every time. Eventually it just goes up to 56, and this keeps going down by 5 every time, like that. So now at this point, what do we do? Well, 56, but 56 is not one of the answer choices. Wish it was, but it's not. Okay, that means we just got to keep repeating this pattern. Now, at this point, I've got only 5, so I really can't do the 6R, but I can do 4R. If I do 4R, I will get 2S plus 2B. Okay, if I do that, that means I'm down to now 1. I got 2S, so this is now up to 58, and I got 2B, so now we are up to 77. All right, so I'm pretty much done with my R's. I can't use R's anymore because I need at least 2 R's in order to get that kind of exchange. But now I can definitely use a whole bunch of R's. Now, B's, I should say. Okay, so let's do that. Let's use as many as possible. So one exchange of 3 B's gives me S plus R, but I can do a lot more than one exchange. I can do probably 77 divided by 3. So I can do probably 25 of those. So instead of 3B, I'm going to put 75B. So that's 25 of these guys. I can afford to do that since I have 77. So that would give me 25S plus 25R. Now I've used up 75, so I'm down to 2 of these blues. 25S brings my S total up to 68, 78, 83. But now I've got a whole bunch of R's now. I'm back up to 26. All right, so now it's like cat and mouse game. We're trying to get rid of this. Okay, I've got a whole bunch of R's, so let's get rid of those. I can probably do, there's 26, right? So I can do that 13 times. So 13 times 2, which is 26, so it matches identical. 26R is going to be 13S plus 13B. So that drops me down to 0 here. And this will bring me up to 96, and this will bring me up to 15. Okay, I think I'm almost done. This 15 I can feed into this system 5 times exactly. So it'll be 15B, and that will give me 5s plus 5r. So that brought me down to 0. This brings me up to 101. Oh, I only got another 5r. Okay, I think I'm finally done now. Now I've got enough to feed that in twice. So I got 4r, and that's going to give me 2s plus 2b. And this brings me down to 1. This brings me up to 103, and this brings me up to 2. But that's it, because in order to feed it into this system, I've got to have at least 2r. I only have 1. In order to get this exchange, I need at least 3b, but I only have 2. So that's it. I'm done. I can't do any more exchanges. Well, how many silvers did I get? 103. So after this big, long, exhaustive process, we got the answer of 103, which is choice E for number 17. If you have a faster way of doing it, by all means, there's nothing wrong with that. The number 2013 has a property that its units digit is the sum of its other digits. That is 2 plus 0 plus 1 is equal to 3. How many integers less than 2013 but greater than 1000 share this property? Well, our range is between 1000 and 2013. So not including 2013 and not including 1000. All right, well, let's make a table and see what happens. Well, we have A, B, C, and D, since it's a 4-digit number, right? Any number between 1000 and 2013 will be some 4-digit number. And that A, since it's between 1000 and 2013, can only be either a 1 or a 2. So I'm going to start with 1, and then later I'll do the 2's. Well, let's figure this out. The property is that A plus B plus C must equal D. That is my rule. So I've got to figure this out. D obviously can't be 0 if A is 1, but it can be 1. If that's the case, this is 0 and 0. And I think that's exhausting my my ways of doing it for A equals 1. And D equals 1. If A is 1, but D is 2, then I've got a couple ways of doing it. I can put 0, 1, or I can put 1, 0. So for D equals 2, I got 2 ways. Keep A as 1, make D equals 3. When it's 3, I've got a few ways. 0, I can put 2, 0, 0, 2, or I can put 1, 1. And that would give me my 3 ways of doing that when D is 3. When D is 4, I've got a few other ways. 0, 3, 3, 0. I've got 1, 2, and I've got 2, 1, like that. So when D is 4, we've got 4 ways. And similarly, you'll notice that when D is 5, there's 5 ways. When D is 6, there's 6 ways, and so on, right? When D is 7, there's 7 ways. When D is 8, there's 8 ways. When D is 9, there is 9 ways. And that's the highest D can be. So all of these guys, you just added them up. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. And when you do, you get 45. Well, 45 is one of the answers, but wait, don't circle it just yet. We have to also do 2. We did A equals 1, but now we have to concentrate on A equals 2. The good news is that A equals 2 we can do very quickly. Can just make a little table over here, actually. A is 2, so that means D must be at least 2. It can't be 0 or 1. So let's try to make it 2. That means one way of doing this is 0, 0. Okay, I've got one possible way. Let's try another value. Let's try 3 for D. Well, that would be either 0 and 1 or 1, 0. But here's the thing. Both of these numbers are greater than 2013, and we have to have numbers less than 2013. So 2013 is 2013, and 2103 is obviously greater than 2013. So these two guys don't count, and neither will any other value greater for D. Like if you put 4, and then you did this, for example, if you did 1, and 1, as you can see, it will be greater than 2013. Or if you did 0, 2, that's also greater than 2013. So the only one when A is 2 that satisfies our condition is this guy, 2002. So we've got this 45 and this 1. You add it up and you get 46. So that is the answer to the question, number 18. Number C, B, A form an arithmetic sequence with A greater than or equal to B, greater than or equal to C, greater than or equal to 0. The quadratic ax squared plus bx plus c has exactly one root. What is this root? C, B, and A form an arithmetic sequence. And as you know, those are sequences of the form A plus D, A plus 2D, A plus 3D, and so on. So let D be the common difference for these three. And that means I can write it as follows. B, I'll just leave alone, but then A will be B plus D. And C, I will write as B minus D. It will just make the math a little bit easier to write it like this. The common difference is still D, but I've written it in a way that makes the calculation faster. Now we have this piece of information. That quadratic has exactly one root. What does that mean? Well, if you recall the quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. When you do this for some equation, you'll get two roots, right? If it has exactly one root, what that means is that this part is equal to 0. And therefore, you would be just left with x equal to minus b over 2a. And some of you may remember the name of this part. It's called the discriminant. Discriminant. So when they say it has exactly one root, what they're really saying is that the discriminant is equal to 0. So that is our direction in this question. Well, let's substitute in these values. B squared, well, b is just b. I'll just leave that alone for now. And then let's put this 4ac on the other side. A is this guy, b plus d. And c is this right here, b minus d. And then if you expand this out, you get b squared is equal to 4b squared minus 4d squared, like that. And then let's put together the like terms, and when I do, I get 3b squared is equal to 4d squared. And then if you take a root of both sides, square root, you get 2d is equal to root 3b. And that's pretty good. So now I can calculate this, that one root. And that one root will be x is equal to minus b over 2a. And a is this guy, b plus d. B plus d. Well, d and b, I have a relationship, so I can substitute that in. Instead of d, I will put in d in terms of b, which is root 3 over 2b. So that means this becomes minus b over 2 times b plus root 3 over 2b. And continuing, that means x will be equal to minus b over, if you get a common denominator, this will be 2 times b plus root 3b. You don't really need a common denominator. And the good news here is that the b's all cancel, so all you're left with is negative 1 over 2 plus root 3. And that is the answer, negative 1 over 2 plus root 3. But interestingly, it's not one of the answer choices, but that's okay. That just means we have to rationalize the denominator. And when you rationalize the denominator, it just means you're multiplying top and bottom by the conjugate. So 2 minus root 3 and 2 minus root 3 like that. So this gives me minus 2 plus root 3. and the denominator will be 4 minus 3, and therefore this is just minus 2 plus root 3, because 4 minus 3 is 1. So minus 2 plus root 3 is the answer, and therefore the correct answer choice is D. The number 2013 is expressed in the form 2013 is equal to a1 factorial times a2 factorial dot 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 am factorial over b1 factorial times b2 factorial dot 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 times bn factorial, where a1 is greater than or equal to a2 dot 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 greater than or equal to am, and b1 is greater than or equal to b2 dot 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 greater than or equal to bn are positive integers, and a1 plus b1 is as small as possible. What is the absolute value of a1 minus b1? 2013 is equal to a1 factorial times a2 factorial, and so on, right? All the way to some m factorial, am factorial. And that's all divided by b1 factorial times b2 factorial, and dot 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 all the way until you get to bn factorial. Now 2013, it will help us tremendously if we factor that into its prime factors. Well, what are the prime factors of 2013? It's 3 times 11 times 61. Or if you want to write it in the other order, might make a little bit more sense, 61 times 11 times 3. And the reason is because a1 is greater than a2 and so on. All right. So you have to think about this for a little bit. I strongly encourage you to attempt this question. Don't get intimidated by the, notation. I promise you that if you learn this question, it will boost your confidence with regard to not just factorial notation, but questions like this in general that tend to be a bit daunting simply because of the notation. So how do I get 61 times 11 times 3 from this whole big mess right here? Well, the good things about factorials is that they cancel each other. For example, if I have 8 factorial over 7 factorial, it cancels, right? All this is just 8, because 8 factorial over 7 factorial is really just 8 times 7 factorial, and that's of course over 7 factorial, and therefore the 7 factorials cancel, and that's why you're just left with 8. So a bunch of these, and probably not too many, maybe only 3, cancel each other to give us 61. So immediately what I thought is 61 factorial over 60 factorial. If I did that, it would cancel to give me just 61. And then if I keep going, I would put in 11 factorial over 10 factorial. Those two would cancel to give me just 11. And then I put in 3 factorial over 2 factorial, and those two would cancel to give me just 3. Okay, this is perfectly valid. Now let's look at the question. A1 plus B1. What is my A1 in this case? Well, my A1 I've chosen is 61. And what is my B1 in this case? It's 60. All right. So what is A1 plus B1? That's 61 plus 60, which is 121. And then therefore, what is the absolute value of A1 minus B1? A1 minus B1 absolute value is 61 minus 60, and that is just 1. Okay, and 1 is an answer choice. All right, well, do I circle A and move on, or do I come up with another scenario? And that's where this question is a little challenging, because unfortunately 1 is not the right answer. There's actually a couple, 2 other ways of doing this. Interestingly, both of them give you the same value for the absolute value of A1 minus B1. So what are those 2 ways? Well, here's the way you will be able to get a smaller value for A1 plus B1. 61 times 11 times 3. You can write it as the following. 61, that's fine, 61 factorial, but over 59 factorial. And I say, well, okay, is this going to work? Well, watch what happens. The 11 and the 10, that's fine. That's perfectly valid. You don't need to change that. But then the last two, you do a little bit of fanciness here. 3 factorial over 5 factorial. That will allow me to also get the same result. Now let's visit this again. What is my A1 and my B1 this time? My A1 is again 61, but my B1 is now 59. So A1 plus B1 is this time 120, which is smaller than 121. That's why this is a better way of doing it. It's the correct way according to the requirements of the question. And now what is my absolute value of A1 minus B1? Well, it's 61 minus 59, and that is, of course, just 2. But let's figure this out. How does this work? For these two, when you do the cancellation, you get 61 times 60. That's what's left. For these guys, 11 is all that's left. And for these, what's interesting is you get something on the denominator. You get 5 times 4. Okay? Well, 61 is perfectly fine the way it is. That 11 is fine. So I've got this guy and this guy. But watch what happens. These three, 60 divided by 20 is 3. And as you can see in a very cool way, you get the same result. Interestingly, there's one more way which gives you the same answer. That is 61 times 11 times 3. If you broke it up as follows. 61 factorial over 59 factorial, so the same way. 11 factorial over 10 factorial, that's fine. But then you write 19 factorial over 20 factorial. That's another way of making this. And of course, you've got to arrange them in a way so that it's in decreasing order. So what I really should have done is written it like this. So not that it really changes our answer, but just to be consistent with the requirements of the question. This also ends up giving you this. And this also ends up giving you the same answer for A1 minus B1. So the answer is 2, and therefore number 20, that would be choice B.